Hello, welcome. Today let's try to solve a Leetcode problem 438. Find all anagrams in a string. So we are given two strings S and P. We need to return an array of all the start indices of P's anagrams in S. So this means this is a P, A, B, C, and we also have a string S. We just want to find the anagrams inside the S. So for example, this is CBA. It is the first anagrams because CBA can also become the ABC. So we're gonna return the first index 0. Now from index 6, we have BAC. So for this BAC, it can also become ABC. So we're gonna have another index 6. So this is the final result. It's gonna be 0 and 6. So we want to find all the anagrams indexes inside S. And let's check the constraints of S and P. It is 3 times 10 to the power of 4. S and P consists of lowercase English letters. So for this problem, we're gonna try to find a data structure to solve the problems. Normally for this kind of problems, this is ABC, we can solve it by using sliding window. So it is a fixed sliding window because this ABC, it is fixed. I mean the length of P is fixed. It is 3. So inside S, we just need to use the sliding window. Use a fixed sliding window. So the size of the sliding window will always be 3. We want to find inside of the sliding window this is 3. If we can find a ABC, BAC, or ACB, or something like that, so we're gonna choose a data structure. It's gonna be hash table. Yeah, so for me in Python, I'm gonna use a counter because counter can be compared with each other. Yeah, it can save me a lot of lines of code. So I don't use the hash table directly, but instead I'm gonna use a counter. So I'm gonna choose 2 counters and compare with the counter. If the counters equal, so for example at this place, this is the counter S and this is counter P. If they are equal, I'm gonna get the first index 0. And from here, BAC, I'm gonna choose this counter and equal to the counter P. So I'm gonna get another index. If I cannot find any index, so it's gonna be an empty array. So for this one, I have index 0, 1, and 2. Yeah, now let me start coding. So for this problem, I call it 2 counter sliding window problems. Yeah, and after solving this problem, I'm gonna continue to solve this similar problems, permutation in string. It's gonna be exactly the same. I just copy the code and change a little bit, and we can solve this problem. Now, let me try to solve this problem. As I said, the window size is fixed, so I'm gonna use a p length. It will be the size of the window p, so it's gonna be the length p. Now I need to prepare some variables, so let me prepare L and result. So the L will be started from 0. This will be my left pointer, and the result will be an empty array. I also need to prepare a dictionary. So this dictionary is prepared for S, is prepared for inside S. So because I'm gonna use this as string, so I will use another variable, so I will name it D. But for P, I will use it directly as a counter. So for D, it will be an empty counter. So I'm gonna prepare a counter, it's empty. And another P, I will directly use it as counter P because I will compare with this D and P. If they are equal, I'm gonna get one of my result inside the result string. Yeah. Now I'm gonna enumerate the right side. So for RC, enumerate the string S. I want to put the characters C inside my hash table D, inside my counter D. So D would plus equal to 1. Now I need to check because this is a fixed sliding window problem, so I don't need to use a while. If I use a while, the window size is not fixed. So for this problem, this P, the size of the window is the length of P is 3. So I don't need to use a while. I can directly use if to check. Yeah, because the window size is fixed. For each of the iteration, the window size will always be fixed. It means the I pointer will be shifted 1 to the right, and the L pointer will also be shifted 1 to the right. And this is also ON. Yeah, and also plus the hash table, it's gonna be 26 times ON, and that is for the time complexity. And you can check the code later, but let's finish the code. So for L R minus L plus 1, this is for the window size. If it is equal to the P length, it means if it is equal to 3 to the window size. So I need to check. Because I'm not sure if I find a result, I have to check it. So I have to check if this D equal to my counter P. If they are equal, I can put the L index inside my result because L index is the first index according to the description of the problems. Yeah. So let's say, yeah, you may return the answer in any order, and yeah, I think it is mentioned. It didn't tell us, but according to the explanation, it is said the substring with the start index. We're gonna always get the start index. It is not mentioned here. It's not mentioned we're gonna get the start index. Yeah, you see, given two strings, return. Oh, it also mentioned here, return an array of all the start indices of P. Yeah, it is the start indices, and also we can check it according to the example. So we're gonna put the starting index inside the result. Now we need to update the window. So how can we update the window? So for the D, it would be inside, it would be SL. So SL should be -1, and the L index would be +1. After updating the window, it means we are safe. So for the next iteration, the window size will always be fixed. So we're gonna like check this one. After this one, we're gonna check this one, and then we're gonna check this one. Yeah, let's check the and also for this P and S, it is 3 times 10 to the power of 4. So yeah, this is why it can pass even though the window size is very big. Maybe it is like uh, like 10,000. Yeah, but this is ON. For example, even this size, the window size, maybe this P is like 10,000. Yeah, and and this is for example, this is the L pointer, this is the R pointer, and the length is 1,000. So for the next loop, it's gonna move one place from here, and the left pointer will also move one place, but it didn't increase the time complexity. So the time complexity is still ON. But here, for the this D and P, if they are compared with each other, there are 26 characters inside the hash table, so it's gonna be 26 times ON. Yeah, otherwise we cannot pass. Yeah, because this is a sliding window problems. Even though the window is fixed, but for each time, we didn't calculate anything inside the window, just at the end and at the front of the window. Yeah, we just do one operation. Yeah. Now, actually, this is the final code. We just need to return this result. Now let me just run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check. Yeah, as you can see, I passed all the testing cases and it's pretty fast. And let me analyze the time complexity again. So here for this for loop, this is ON. And inside here, as you can see, this is just a if check. We didn't even use the while check, so this is just ON. But inside there is another if. This is for D compared with P. This is a counter. So there are 26 lowercase English letters, so it will be 26 times ON. And that is for the time complexity. And for the space complexity, that is only O26. So it's similar to O1 because 26 is a constant number. Yeah. But here we're gonna have another array. So this array, we are not sure how long it should be. So the space complexity would be on, because inside of this L, it can be the on. The length can be on. For example, if there's only one character for P, for this P only one character, we're gonna compare one by one. So it's gonna be on for the space complexity. Now let me just copy the code and use this code to solve another problem, because basically they are the same. But this problem will be a little bit harder, and this is for permutation in string. Yeah. Now let me just copy the code and let's try to understand the problem first. So we are also giving two strings S1 and S2. Return true if S2 contains a permutation of S1. As you can see, the permutation is also similar to the anagrams. Yeah. So for this permutation, it can be AB or BA. And you can see here is a BA. It means we've already found a permutation. Yeah, so we're gonna return true. If we didn't find, for this example, AB, we didn't find AB or BA, we're gonna return a false. So I'm gonna use exactly the same code, but for simplicity, I will just make a comment, because I will write the code. But you can compare with the result. It's gonna be exactly the same. So yeah, I'm gonna prepare two counters. So I'm gonna use D1 and D2. So D1 is for counter S1, D2 is for counter S2, because we are giving S1 and S2. So let me write D1 and D2 should be counter S1, and D2 would be an empty counter, because I will use it later. Yeah, because I will enumerate this S2 array, S2 string, and inside I want to find if I can find a permutation of S1. So I will gonna use an empty counter for this D2. I also need to prepare let me see. I also need to prepare a L pointer would be 0. Now I will loop through. Let me copy the code from here, I think. Yeah, basically it would be the same. Let me just copy the code. So I need to, for RC, enumerate this S2. So my counter D2 will be updated with 1. So inside I need to count the characters. Yeah. Now I need a check. So how can I check? I need a while check from here. Yeah, let me see if it is a if check or while check. Yeah, let me try to use a while check first. So while this D2 say, I mean this character, while this character, the number of this character is more than the D1 say the counter of D1, because the counter of D1 is fixed. Yeah. So what I need to do, I need to update the window for this S2. So the window, how can I update this? So finally, the L pointer must be +1. But before that, I need to update the window of S2. So this means the D2, the number is higher. Yeah. This means it cannot be equal. If I wanted to make the D2 equals to D1, I have to shift the left window, left side. Yeah, I have to shift this L index. So how can I shift? So it would be D2 S2 say should be -1, because I'm gonna shift the window, the left pointer, the left index. So I have to first take out this character for my counter D2, and then I'm gonna shift the left pointer to one place to the right. Yeah, to one position to the right. Yeah. So if the window, up to now the window is broken, if the window is fixed, I have to check if there is a possible result or not, because there might be no possible result. It can be a false. So I have to check if this D2 equals to D1 or not. If I find a true, so I'm gonna return a true. If I didn't find, finally I'm gonna return a false. Yeah, so now we can compare the code a little bit. As we can see, there are also two counters. So there are also two counters. One counter is the empty counter for the D2. Another counter is for S1. It's exactly the same. And then we're gonna enumerate. Yeah. So inside we're gonna update this D2. It's also the same. And here, because the window size is fixed, so I got for that question, I just needed to check if the length is equal to the length. And inside this if, I gonna put my answers inside the result. But for this problem, I just take it out. So for this while check, I just want to check if the window is broken. So I gonna update it. Yeah. Until the window is fixed. Why don't I use a if check? Because the window is not fixed. I'm not sure. Yeah. Because for this AB, if this is a E, I gonna get a false. The window is updated to this I. The window will be updated until it comes to here. For this B, it is okay. So the window will be expanded to 2, and now I get an answer. And then, yeah, because this will be a return. Yeah. But I believe the if we will check the if later. But up to now, let me just run it to check if it works. So for this one, there's an error. So yeah, I think this is not S2C. This should be D2C because we've already found this character. Yeah, because up to now the character would be counted by 1. This is character C will count. Yeah, will count 1, and then I have to check this character. I think there's a typo. So if this character is more than D1C, so for D2C should be -1. Now let me run it. Yeah, I got a false. Yeah, it is not D2C. It should be SL. It should be S2L. Yeah, because I want to shift to the left pointer. So S2L, for example, it must be at the left side. Yeah, now it works. I don't know why I made a mistake. Let me check why I made a mistake. S2C. Oh, I did a S2C because the C is just a character. It should be S2L. Yeah. Yeah, because L is the left pointer, and this S2L is this character E, for example. Yeah. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed, and it's pretty fast. Now let me change a little bit. If we can change this while to if, can we do that? I believe we cannot do that because let me think. So if this one is more than this one, I have to fix it. Yeah, I'm not sure. Let me just run it. Yeah, it seems okay, this if. So if I find it is more than this one, I have to fix one time. But that is just 2 testing cases. Let's submit all testing cases. Yeah, we can maybe we can find some examples like this kind of example, but definitely this if will not work. Yeah, because we have to check all the characters because the window is not fixed. It's not like the last question. This is a little bit different. Yeah, and for this K and Y, so Yeah, I'm gonna not explain why, but basically this window, because this window is not fixed. If the window is teasable, it's not fixed, we have to use a while to check. Yeah, if this character is more than this D1C, it doesn't mean at the left side it must be that character. It have to shift it to one by one to check. Yeah, so that is why we have to use a while loop for this problem. Yeah, except that everything would be exactly the same, as you can see. Yeah. Here we also check if the window is broken. If the window is broken from here, we have to fix the window. Now the window is fixed, but the window after the window fixed, it doesn't mean we have a result. Yeah, because we have to check if there is a AB inside. For this example, there is AB, but the window is fixed at B, but there's no AB, so we have to check. Yeah, we cannot return true directly. Now let's analyze the time complexity. As S1 and S2, the length is 10 to the power of 4, so the time complexity is 26 times ON. Thank you for watching. See you next time.